Consider 2 point-charged objects separated by a distance of 2.51 centimeters. The charge on the left-hand object is positive 27.5 microcoulombs. The charge on the right-hand object is negative 27.5 microcoulombs. And they have given us 4 different scenarios. Before we move on to those, let's first draw a picture just to help us visualize this problem a little better. So we have 2 objects, one on the left and then one on the right, and their distance is the distance between them is 2.51 centimeters. And so the charge on the left one is positive, and then the charge on the right one is negative, and both have the same magnitude of charge. And let's just change the microcoulombs into coulombs and the centimeters to meters, just so we have a uniform unit, so we can use our formulas. So this will just be 27.5 times 10 to the negative 6th coulombs. This will be negative 27.5 times 10 to the negative 6th coulombs, and then this will be divided by 100, 0.0251 meters. So these are our 3 values. So the first scenario is we are asked to find the strength of the electric field due to the left-hand object, so this one, at the location exactly halfway between the 2 objects. So somewhere just over here. So for this we are going to use our equation that the net, or the magnitude of the strength of any electric field at any given point is equal to a constant K times the Q, the charge of the one object that is in question, and in this problem it's the left-hand object, and R squared, so the distance from the point that they have given us, which is halfway through these two, to this left-hand particle. So it'll just be half of 2.51 centimeters. So we can plug in the information from the problem. E is equal to, so the constant is 8.99 times 10 to the 9th, and the charge on the left-hand object is positive 27.5 times 10 to the negative 6th coulombs, and the distance will be just half of 2.51, and then we square that, so just 0.0251, it has to be in meters, divided by 2, and then just square all of that. So we can just put all of this into the calculator, and when we do, we get 1.570 times 10 to the 9th, and the units are newtons per coulomb. So this is the strength of the electric field at the halfway point in relation to the left-hand point-charged object. So the next question is the strength of the electric field due to the right-hand object at the location halfway through between 2 objects. So it's the same question, same data, just the right-hand object. And so for this, we have to keep in mind that in this formula, the charge over here, it's actually the magnitude of the charge. So you can see these absolute value signs. That means that it doesn't matter if it's positive or negative, and since both of them have the same magnitude of charge, just opposite signs, it'll just be the same number. It'll be 27.5 times 10 to the negative 6th, and the rest of the numbers will be the same. So the strength of the electric field due to the right-hand object is just the magnitude is the same on this side and on this side. So the answer to this one will be the same as the answer that we just got for the previous one. So 1.570 times 10 to the ninth newtons per coulomb. So the next question is, find the strength of the net electric field due to both the objects at the location exactly halfway between the two objects. So this word net, it just means add the two, just add these two, so you can add these two or just multiply them by 2. So 1.570 times 10 to the ninth newtons per coulomb, and then just multiply that by 2. It's the same as adding it to adding both of them, and we get 3.13 times 10 to the ninth newtons per coulomb as the net strength of the electric field at the halfway point. And then the last question is to find the force on a proton placed halfway between the objects. So for this one, we are going to use the equation F is equal to EQ. And so in this, it is just basically saying the force at this given point, this halfway point, which has been the same for all 4 of these scenarios, will be equal to the net energy at that point multiplied by the charge of the object, and in this case it'll be the proton whose charge we will use. So F will equal capital E, which is this number that we found in this problem, the strength of the net electric field. So 3.13 times 10 to the ninth. And then Q will be the charge of a proton. So, and the charge of a proton is 1.602 times 10 to the negative 19th coulombs. And so we can just multiply these two in the calculator, and we get 5.01 times 10 to the negative 10th, and force is in newtons. So this is the force on a proton that will be placed exactly halfway through these two objects.